Electronic components, take one. All right, we'll be looking at electronic components. First, you have to remember that we're going to be using the types of measurements watts, ohms, current, and volts when we're talking about electronic components. You should remember those from an earlier unit. The first thing we're going to be looking at is alternating current. Alternating current describes the flow of charge that changes directions periodically. As a result, the voltage level also reverses along with the current. AC is used to deliver power to houses, office buildings, and etc. We will not be using alternating current for any of our experiments, but if you want to get into advanced electronics, alternating current does bring a whole lot of fun challenges. What we're going to be using is we're going to be using direct current. It is a bit easier to understand than alternating current. Rather than oscillating back and forth, direct current provides a constant voltage or current used in cell phones, computer monitors, and electric vehicles. Direct current is very easy. It's the red and black power that we see whenever we see batteries or some other battery powered device. The first thing we're going to look at is all the components that we're going to be looking at create a circuit. And what is a circuit? A circuit allows energy to flow from the higher voltage to the lower voltage. It's how we get a flashlight to light up, the lights to turn on, and many of the other things we have electronics do for us. Every source has a positive and a negative. Not only is that a life lesson, but it's also how electricity works. The positive is usually called the hot side, and the negative is the area where it comes out. It's also called cathode and anode. We'll look at those later. The components guide and flow components guide the flow and affect the outcome. Each component has a different effect on the flow of the electronic components or of electricity, and it will affect what they do. For example, light up, turn things on and off, as well as change power. We also have a couple different types of circuits. When we're talking about circuits, the first thing we got to watch out for is a short circuit. A short circuit is where the electricity itself or the voltage feeds back into itself. Since the voltage isn't really disappearing, it builds up, thinking it can flow infinitely and eventually causes the circuit to blow up, usually spectacularly. In an open circuit, we have an incomplete circuit. It means the electricity flows out but has nowhere to go, and therefore, it doesn't actually do anything. In a closed circuit, we have a complete and functioning circuit. A closed circuit is what we're always looking for. One of the most important components when we're building any sort of electronic device is wire. Wire comes in two different types and has one major measuring function. Stranded wire is many little wires banded together. These are a lot more flexible and easy to work with, but unfortunately, when it comes to soldering, they can be a little difficult. Solid wire is a wire with a solid core. It's a lot stronger, but a little less flexible. And gauged wire. When you gauge the wire, you look at the thickness of it. Looking at the thickness of wire is important because the thickness of the wire affects how much voltage can flow through it. You don't want to have too big or too small of a wire when you're looking at what you're going to be making. You want to make sure that the gauge fits your electronic components perfectly. First up is the most basic component, the resistor. The resistor's resistance limits the flow of electrons through a circuit. In other words, what it does is it takes too much power and it pares it down so that there's just enough power flowing to the components so that they don't blow up. Resistors have different values based on how much they limit, and they're measured in ohms. Ohms are generally the unit used for resistance. You can see here that the symbol for ohms is the omega symbol. When you're gauging a resistor, what you're going to do is you're going to look at the bands of color on it. And then you're going to use those bands of color to figure out exactly how many ohms of resistance it has. The more resistance it has, the more electricity will cut down flowing through it. So here you can see the code used, and you can add them up. For example, if it was to have gold, gold, green, and then gold, you would have a different number. So here we have, yellow, purple, orange, and then gold. On this one, you have in the tens place, you have the 4, you have the 7, and you have the third digit on the 5 is here. Sorry. So on the multiplier is by 10,000. I'm sorry, by 1,000, and it's plus or minus 5%. Let's do that over again. Here we have resistor color codes. So let's take a look at the one on top. It has a yellow band, so we can see that it'll come down to the 4, that's the tens place, the 7, which is the single place, and then over here on the right, we have a multiplier, so it'll be multiplied by 1,000. So we have 47,000 ohms of resistance. It has a plus or minus of about 5%. I would recommend a smaller plus or minus because what you want to do is you want to have it be as close to what you need as possible, at least in precise electronics. Next up, we have switches. Switches come in two types, momentary and maintained. A momentary switch is something that you would press to reset something, where a maintained switch is more like a light switch, where you would turn it on or turn it off. A switch can be used to open, close, or interrupt a circuit. By opening a circuit, a switch will turn something off. For example, if you're going to open up a circuit, you would be resetting something. If you're going to close a circuit, that would be like touching a key on a keyboard. You'd be closing it, making that connection. Or to interrupt something, that would be used if you have voltage to stop something from happening temporarily. It can also be used to control actions. An example of this would be a joystick, which is 4 to 8 switches in line used to individually be pushed to give multiple commands using one main switch. Here we have a GIF of a switch and how it works. You can see here that we have the power coming through, and as the switch is closed, the LED lights up. This is the resistor, this is the light emitting diode, and this is our power supply. There are a couple different types of switches. A potentiometer is really just an adjustable resistor. It changes the amount of resistance that's going through the switch at that time. It can go from all of it being resisted to being off to no resistance whatsoever. Usually this is used in something like turning the volume up. We have a normally open switch, switches that are not connected until actuated. And by actuated, I mean touched or moved or manipulated so that they work. A normally open switch would be similar to keys on a keyboard. We have a normally closed switch, switches that stay connected until pushed. For example, a reset button on something. Here we have some of the uses for switches. We have keypads for typing in numbers. We have game controllers, obviously for playing games. We have doomsday buttons for launching nuclear weapons to end the world. We have a ignition switch, which is used to start a car, and turning a light on and off. Next up, the electronic component is diodes. The function of a diode is to control the direction of the current flow. Current passing through a diode can only go in one direction. Current trying to flow the reverse direction is blocked. This is excellent for allowing current to go towards what you need without having the current flow back into electronic components you don't want to be fried from the component going back to. Usually this is used when multiple directions of current are coming in at one time. A deep understanding of diodes can help you build many things. An example of a diode being used is when you have power coming and then being split into multiple sources. That power will, for example, light a light, turn on a switch, or have something else happen. You don't want the small amount of power used to light a light be fried by the large amount of power used to do something else. Here you can see the symbol for a diode on an electrical diagram or on a board is the anode, or the positive side, comes in, and the arrow points the direction which is flowed. At the cathode or negative side is where the power goes out. The power cannot reverse. This acts like a wall, stopping the power from going through it in the symbol. Next, we have a light emitting diode. This particular type of diode not only stops energy from going in one direction, but it also gives off light. Generally, light emitting diodes are used to drain the power off a capacitor or to light things up for fun. They can be a lot of fun to work with. How are light emitting diodes different from bacon? Well, light emitting diodes themselves are fun until cooked, where bacon's only good after it's been cooked. Once you burn up a light emitting diode, it will no longer work. It is not very exciting. Polarity matters. When it comes to light emitting diodes, if you do not have the diode in the correct way, the light itself will not light up. That means that the light emitting diode will not actually be a light emitting diode. It will be stopping flow coming from the wrong direction. Here's a great chart that you can go back and look at on how diodes work. Quick suggestion is if it blinks quickly and then never works again, you have burnt up the diode. Here we have capacitors. Capacitors are a very unique piece of electronic components. They have the ability to store energy. They're like a fully charged electric battery. This is what I was talking about when I said that light emitting diodes can be used to drain off the energy. If a capacitor is storing energy, a light emitting diode will allow it to slowly release the energy without having to do anything as part of the board. You see this when you unplug a computer from the wall and it still has lights on until they eventually run out of power. Common applications for capacitors include local energy storage, voltage spike suppression, and complex signal filtering. Don't worry about the complex signal filtering, but for example, a capacitor works so that something that you want to use will immediately turn on, or if you're not entirely sure about how much voltage will be coming into something, the capacitor holds the voltage at a certain amount until it can be moved forward so that if too much voltage comes, it won't affect the electronics down the line. That brings me to voltage regulators. A voltage regulator is designed to automatically maintain a constant voltage level. A voltage regulator may be a simple feed forward design or may include negative feedback control loops. It may use an electromechanical mechanism or an electronic component. Here you can see what a voltage regulator looks like, but pretty much what a voltage regulator is used for is to make sure that the amount of power coming through gets to the right place. If too much voltage comes in, it'll be grounded. In other words, it'll be bled off so that only the right amount of voltage goes through. This is also important for making sure that the amount of voltage your components get is not too much. Finally, we have transistors. The transistor is a component that is incredibly complex and has a lot of uses. Unfortunately, without teaching you college level electronics, you just have to understand that transistors are magic and do exactly what they're supposed to. A breadboard. These are great for making circuits and prototyping. They require absolutely no soldering. Here you can see an example. We have the positive 5 volts coming in. You can see that the wire comes off of here, lights up the electrical diode, and then we have the resistor, which pushes it forward through the switch. The switch itself will maintain itself off until it's pushed. Once it's pushed, it'll make the connection to here, and the diode will light up. We have the same idea over here, except in reverse, where the light will stay on until the switch is turned off. This way you have one that's always lit up and one that lights only when you push the button. That concludes the parts for electronic components. If you have any questions, please let me know.